Welcome, grade 11s, to this lesson on manipulating graphs. In data handling, we are able to change the way we display data to emphasize a point of view. Most of our focus in data handling is how to represent data accurately. However, it is possible to represent data accurately, but to give a false impression of the information. Advertisers and marketers use this tactic to show that their product works better or is more popular than the other products. Let's look at an example of a graph displayed in two different ways. MacGyver and his teacher are comparing two histograms. Let's join them now.
Let's start by comparing these two graphs. They represent Spaza Shop sales. I would like you to look at them carefully and tell me what each graph shows us about how well the Spaza Shop is doing. Have a look at this one first. What do you think it shows us about the sales for the Spaza Shop?
Well, I think that this graph shows that the shop is not doing very well. It seems to be headed downhill. Sales are dropping every month.
How about this one?
This one looks alright. It looks like a solid business. The sales are around about the same every month.
Well, what did you say if I told you that they're actually the sales figures of the same shop for the same time period?
But they don't look the same.
Why don't you take a closer look? Have a look at the figures for April.
On the first graph, it gives you about 13,690 Rand. On the second graph, it gives you almost 13,700 Rand. Hey, you're right. The numbers look the same, but the graphs are different.
Now, how do you think such different graphs were drawn from the same information?
I'm not really sure.
Have a look at the numbers on the vertical axis or the y-axis.
Hang on, they're different.
Well spotted. The scale on the vertical axis is different for each graph. Have a look at the first graph again. The vertical axis scale has exaggerated the differences between the amounts from month to month. Exaggerating the scale on a graph like this is a common technique that people use when they want to use the data for a particular purpose. In this case, you can see how effective it can be. You interpreted the graphs quite differently, although the data they represent is in fact the same. But that's not the only technique in use here. Tell me, MacGyver, what is the lowest number on the vertical axis for each graph?
The second graph starts at 0. And the first graph starts at 13,500. It doesn't start at 0.
Does that make a difference?
Yes. Look at how stretched out the numbers are. Even though the sales decrease, the changes are actually only a couple of 100 Rand per month. This graph makes you think that this shop is heading for disaster.
How would you decide which graph is better?
I'm not sure. I suppose it would depend on the situation.
Correct. There are some situations in which you need to see small differences between the amounts of money. So it is not wrong not to have the 0 on the graph. But we need to be aware of how the graph is drawn. It's the responsibility of the person reading the graph to make sure that they interpret the information correctly. But graphs should always be labeled clearly so that we're less likely to draw the wrong conclusion.
But why would anyone want to misrepresent the sales of a business?
Well, there are some possibilities. If someone wanted to buy the shop for a lower price, they could use the first graph to show that the price of the business is too high because sales are going down. Another person could use the second graph to show that the business has a steady income and is therefore a good investment.
Those histograms showed the same set of data, but each one gave a different method. Let's look at them again. This is the first graph they looked at. We can see that a possible first impression could be that the sales are decreasing every month because the graph is sloping downwards. The y-axis, the vertical axis, starts at 13,500. Looking at the second graph, we see that it starts at 0 and all the bars seem to be the same height. Both graphs are plotted using the same data, but both graphs paint a different picture. They look different because the scale on the y-axis is different. In the first graph, the y-axis goes up in 50s. In the second graph, the y-axis goes up in thousands. This is why the two graphs look different. Let's go back to MacGyver as he and his teacher look at another example of how scale can change the message of the graph.
Here are another two graphs showing sales over a different period of time. The owner wants to get a bank loan to expand her business, so she needs to convince the bank that her business is doing well. Which of these two graphs would create a better impression?
I'd say the first graph.
But what is it that makes this graph more impressive?
For me, I think it's the slope of the graph that makes the difference.
That's it exactly. It's the slope in the first graph that makes it appear more impressive. The first graph seems to show a sharp increase in sales over the last 6 months. The steep positive slope implies that things are really improving quickly. And the second one is flatter. It shows an increase, but it's not as convincing. However, if you worked out the values of the slopes, you would find out that they are the same. But what makes them look different? Do you know?
I think I've got it. Look, the horizontal axis has been stretched. The months are spaces further apart on the second graph.
Once again, we see that the same set of data is used to draw both of these graphs, and yet they seem to give a different message. This shows the important role that scale plays in plotting graphs. Thank you for joining us, Grade 11s. Remember that you can find more resources on our website and practice questions in the Working with Data Handling task video. Goodbye.